Good afternoon. I hope you have enjoyed the meal and don't be so much tired. The work I'm going to present has been carried out by the researchers from the Ceramic Technology Institute in Castellón, ITC, and in collaboration with our colleagues from the Technology Institute from the shoe sector in Alicante, also in Valencia region. As I just have a little minutes, I just I'm going to present just some parts of the paper. I recommend you to read all because there are some more information. We have selected around the several reference surfaces we are using in different test methods for slip resistance. We selected the Eurotile 2, which is also known as Portuguese style or Paviger style. It's a flat medium rough surface, and which has been used for ISO 13287 shoe test with a shoe tribometer, and also is used as a reference for verification in Annex B pendulum and Annex C tribometer in the future in the project of European standard 16665. And we also include the reference surface we are using in the Spanish standard, which is another very similar to the method of the European project. Is for pendulum test method in wet conditions using rubbers 57. And we selected because both surfaces, which are very different surfaces, as you can see. The Spanish reference surface is a low roughness texture surface, but gives very similar results when we test with both pendulum with both sliders, 757 and 96, and also when we test with both 3000 method. The first part was developed by our colleagues from the shoe sector. They selected 14 shoes, commercial shoes, all there. Some of them were professional shoes, and another are conventional or casual shoes. And they tested both surfaces, sorry, both in flat contact mode. The shoe tests include three conditions of tests, but the more common are flat mode and heel contact mode, which is in your right. It's a little different that has shown our American colleague before. The contact is in 6 degrees only, but it's the reference, and there are some regulations for professional shoes in these conditions. As you can see, in both situations, I have plotted also the requirement for the SRA class in both conditions is 0.3032 and 0.028 for both contact methods. And you can see that the differences between the least slip resistant shoe and the best resistant shoe are around 0.24 and 0.23 sorry, in both situations, which are most of the same order that the flooring are contributing in that case. Because, for example, the Eurotile 2, as you had seen before, gets values with a pendulum of 0.28. So it's more or less the same range of contribution. We are working a lot with our colleagues from the shoe sector because we are aware that we cannot talk about slip resistance talking only about floorings, and they are aware that they can talk about slip resistance if they consider also the surfaces. They selected 5 shoes covering all the range from, according to their opinion, covering all the range of the common shoes in the market, conventional and professionals, from 0.15 and to 0.30, some more values. And in this graph, we plot in full color RARs the results obtained with with the tribometer test. This includes different materials. For example, most of the shoes are based in polyurethane materials, but for example, we include EVA shoes, which are a very softer material, and of course, it's not for professional uses. You can see in the photograph this white shoe, and we plot in discontinuous bars the results we get with ramp, of course, testing with technicians, qualified technicians for this test, and using the same issues. Comparing both situations, we are plotting in the red line the average value of the 5 shoes for each floor surface. And you can see that in the discontinuous line in blue, which we are plotting the results from the average of the 5 shoes with technicians on the ramp, that there are a contribution from the adapting gait ability of the technicians in these situations that can contribute also to the friction, to the actual friction when using shoes. Probably we cannot compare directly both results because the ramp, the way to walk on the ramp is not the same way to walk when we are on a flat surface, which more or less is try to simulating the shoe tribometer. But more or less we can conclude that there are also contributions when we are testing with water contamination conditions. When we compare the results when testing with glycerin or oil, it seems that the human ability is not relevant, because in these situations the friction is probably so low and the slip is quite more quick in the movement, and the humans are not able to correct this situation. And this is one of the most interesting results. We selected, our colleagues selected four shoes covering different patterns and different materials. This is the one you have seen before in the photograph, EVA material with a very low profile sole. And we prepare some samples of the 2 standard references, the Eurotile and the STDP, abraded using the machine, the method from Karlsrotens. And the results you can see in this square rectangular green are the values of the results from the original surface in the Eurotile. When we abraded in a initial stage, just only 50 cycles, we see a slight reduction. And when we tested after 500 cycles, which is supposed to stabilize the surface according to the previous studies, the changes are some more significant. But please note that the least slip-resistant shoe seems not to change significantly when we are abrading the floor surface. In the case of the STDP, we go directly to the 500 cycles, because we know that there's a material that have a better wear resistance. And you can see that also the change when testing with shoes with a tribometer, a shoe tribometer, are low significant. This is important, but when we compare with the results getting when testing with flooring methods, you can see in the graph in green color the results from both 3000, in blue color the results of pendulum using slider 96, and in red using slider 57. We have included also the control that for the tribometer test, the shoe tribometer tests are used in order to control the surface before to test the shoes, which which is using also slider 96. And you can see that it seems that flooring methods are excessively sensitive to the change in roughness, because the wear in these conditions most only in that case change the roughness over the surface, not the profile. And another I think important conclusion is that when we compare different flooring test methods with the requirements, you can see in this continuous line in red for the slider 57, in white, in blue for the slider 96, and in green for the BOT 3000, that we can consider that a surface may be safe or not safe, just changing the method. So our conclusion is that it's very relevant to try to modify thresholds in order to get similar classifications independently of the method we use. Because in fact, the users don't have so much information in order to decide about this. So we need to give some clear information to the users. And that's all for my side. Thank you very much.